Okay, this is section 5.4, proofs using the transitive property, or using transitivity. This is our first real chance of doing full-fledged proofs. When we do a proof, it has four basic parts to it. The given information, what we're trying to prove, the drawing, and then the argument. And the argument is what we're going to have to fill in, and that is statements and conclusions that go from the given to what we're trying to prove. We're going to go back and start with this situation of the two parallel lines in the transversal. The exterior angles are the ones that are on the outside of the parallel lines. So the exterior angles are 1, 2, 7, and 8. And then the interior angles are 3, 4, 5, and 6. Interior means they're inside of the parallel lines. Exterior, they're outside of the two parallel lines. So here's our first real proof. The given is that A is parallel to B. In symbol notation, of course, that would look like this. And we're trying to prove that angle 3 is congruent to angle 5. So we're going to start with, sometimes we start with step 0. I'm going to go ahead and write that in there. Step 0 is the given information. So it is justified by just saying given. So A is parallel to B, and that's given to us. Now, we need to, this one's going to take 3 steps, and we need to start from the given and work our way from what we know to what we're trying to prove, and that is angle 3 congruent to angle 5. So let's first start with something that we can prove about angle 3. So I'm going to start with by saying that angle 3 is congruent to angle 1. And that will be justified by the vertical angles theorem. We've done that quite a few times. Hopefully we can remember that piece. Now we're going to go from that step to another step. And now, since we've said angle 3 is congruent to angle 1, now we want to say something about angle 1. So angle 1 is congruent to what other angle? And the one we want to tie it back to is we want to take it to angle 5. So angle 1 is congruent to angle 5 by the corresponding angles postulate. Remember, corresponding angles are in the same position from the top set to the bottom set. And if our lines are parallel, then those are going to be congruent. So our third and final step here is that angle 3 is congruent to angle 5 because they are both congruent to angle 1. That is our transitive property. And this time we're going to say transitive property of congruence. So there's a 3-step proof using things that we've already now used, the vertical angles, corresponding angles postulate, and the transitive property. And we just proved this new theorem. This is called the alternate interior angles theorem, or we will often abbreviate it as the AIA congruence theorem. AIA standing for alternate interior angles. So if two parallel lines are cut by the transversal, then the alternate interior angles are going to be congruent. So, and it's a biconditional, so it goes in both directions. Of course, the picture is the two parallel lines in the transversal and this angle to this angle. And so we just proved that this theorem is true for that last problem, and it is also true in all parallel lines in transversal situations. Now we also have the alternate exterior angles theorem. And again, this time given A is parallel to B. We've got our two parallel lines. We'll call this one A and this one B. Our transversal. I'll number the angles this way. So we want to prove a pair of alternate exterior angles. So alternate interior angles are like 2 and 6. So a pair of alternate exterior angles would be angle 1 is congruent to angle 5. So step 0, A is parallel to B, given. I think now would be a good time to maybe pause this and see if you can do it without me, and then I'm going to go ahead and go through it. So if you want to pause and try it on your own. All right, now I'm going to go ahead and continue and finish this up. And let me go to a different color here. So we're going to go from angle 1. I'm going to say angle 1 is congruent to angle 7. Now, this is not the only way to do it, because we could also say that angle 1 is congruent to angle 3. So if you did that, that would be okay. Angle 1 is congruent to angle 7 by the vertical angles theorem. And then we could say that angle 7 is congruent to angle 5 by the corresponding angles postulate. And then we can finish up by saying angle 1 is congruent to angle 5 by the transitive property of congruence again. Now again, you could have done this one also by saying angle 1 is congruent to angle 3 by the corresponding angles postulate. And then your second step would be angle 3 is congruent to angle 5 by the vertical angles theorem. And then your last step would be the same as mine. Now, real quick, I'm going to do a couple of constructions, and we're going to construct an equilateral triangle, starting with a segment. So you'll have, if I ask you to do this, I'd start with a segment. I'm going to call it AB. We need our compass. So to make it equilateral, we're going to put the compass point on A and the pencil at B. And we're going to draw that arc, or that part of the circle, from there. And then without changing the compass, then we do the same construction from B. And the point where those intersect, that's going to be point C, or your third point of your triangle. And then we connect those. All three sides are going to be congruent. And we can use that definition of circle to maybe prove that. I'm not going to show you that right now, but it's very much like the perpendicular bisector construction, except on this one you have to go endpoint to endpoint. That's what gives you the third equal, or the two equal sides. Now, constructing a circle through three non-collinear points, we're going to start with three non-collinear points. And we're going to do two perpendicular bisectors. So I'm going to call this A, B, and C. So the first thing I'm going to do is the perpendicular bisector of AB. Draw that out. Then I'm going to do the perpendicular bisector of BC. change the compass just a little bit on that one, but now here's where you have to pay attention. Where's my intersections? Here's one of them, and the other one is right here. So I'm going to line those up. Draw it out. The center of your circle is where your two perpendicular bisectors intersect. So that's the center of your circle. So to finish this, we put the point there, and then we'll put the pencil on any one of our 3 points. I'm going to put it at B, go to red maybe here, and hopefully this will go through all 3 points. And it does. So to do the circle through 3 non-collinear points, you're going to do 2 perpendicular bisectors and find where they intersect. Hopefully that helped as we do using the transitive property again to do a proof.